All right. Welcome again to our continuation of the example that we began of representing our function f of x is equals to x minus x squared in Fourier series. Now, in our previous lessons, we had obtained the value of a naught over 2 as negative pi squared over 3. We also obtained the value of an as negative 4 over n squared into brackets negative 1 to the power n. Then now we are remaining with bn. So that is what we are going to obtain in this lesson. And remember, our function is f of x equal to x minus x squared, and the interval is given from negative pi to pi. And in our previous lessons, we said that bn is always given by 1 over pi, the integral from negative pi all the way to pi, f of x sine of nx dx. So that's what we said, that bn is given by 1 over pi, the integral of negative pi to the pi, because of course we are given the interval here. It is negative pi to pi, the sine of nx dx. So what we are going to do, we will substitute our f of x here, which is x minus x squared. So this will be equal to 1 over pi, the integral from negative pi all the way to pi. Now we are going to have our function x minus x squared, close brackets, sine nx dx. That is 1 over pi, the integral from negative pi to pi, into x minus x squared, the sine nx dx. So we are going to obtain our bn by integrating this function. So maybe we can write this one afresh. We can write that one afresh, so that bn will be equal to 1 over pi, the integral from negative pi all the way to pi, x minus x squared into brackets, the sine of nx dx. So this is the function that we are integrating for us to obtain our b sub n. And when you look at this kind of a function that we are integrating, it has two parts. It has two parts, that is x minus x squared and the sine of nx dx. So this one, when you see a function that has two parts, then that reminds you of integration by parts method. We have the part with x minus x squared, then we have the other part of sine nx dx. And for the method of integration by parts, we said that we apply this method uv minus the integral of v du. This is the method that we apply and integration by parts. And in our previous lesson, I remember that I told you that you begin by letting this part to be u. You begin by letting that part to be u, this first part here to be u. Then you let the second part from where we have the sine up to where we have dx to be our dv. So our first part will be x minus x squared. Then our second part will be the dv, that is sine nx dx. And I showed you how to integrate using part method directly without having to repeat all the steps that you have to repeat for you to arrive at the answer. And that is the same method that we are going to employ here. Okay, so now we are going to have, you make sure that you are following keenly. We are going to have bn is equals to 1 over pi. Now, we said that for us to integrate this function or a function involving two parts like this, that by parts method, after letting u and dv, we said that we begin by writing our part u, which is x minus x squared. We begin by writing our part u, which is x minus x squared. Then it is supposed to be uv. It is supposed to be uv, and therefore, for us to obtain the v, so that we are going to have a product of u and v, we are going to integrate the dv for us to get the v. And of course, the integral of sine gives us negative. And the integral of sine nx will be negative 1 over n cosine nx. So I multiply by negative 1 over n cosine nx, like that. Then minus, this minus which is here, I'm going to move with it here, so it will be minus. You come back here. So this one, we shall be differentiating the first part as we integrate the second part with respect to x. So when you differentiate this part, that is x minus x squared, we are going to get 1 minus 2x. We multiply by, of course, we move with our negative sign. We move with our negative sign here. We now integrate cosine nx with respect to x. And when you integrate cosine x, you will get positive 1 over n, positive 1 over n sine nx. But remember, we have another 1 over n here. So 1 over n times 1 over n will give us 1 over n squared. Then it is supposed to be sine nx. Don't forget that this negative is the one that was here. We have just moved with our negative here. Then again, we subtract. And remember, we continue with the process until the differentiation here becomes 0. We continue with the process until the differentiation here becomes 0. So we continue again. When you differentiate this part, so we shall be differentiating this part as we integrate this part again. So we differentiate this part, we are going to get negative 2. Now, then we multiply by, we now integrate this part. Once we integrate this part, we are going to get negative cos. So it will be negative 1 over n cos nx. So it will be negative 1 over n. Negative 1 over n, like that. Supposed to be a continuation. Negative 1 over n. Then remember, there is another negative here. Negative 1 over n squared. So once we multiply negative 1 over n squared by negative 1 over n, it will give us positive 1 over n cubed, the cosine nx. Cosine nx. Then we now close the brackets. Remember, this one is x, do not forget. And of course, we are working with our intervals. We are working with our intervals negative pi to pi. We proceed. We are going to simplify so that our bn, I'm going to simplify, and then our bn becomes, b sub n becomes 1 over pi into, so we begin with this one, negative 1 over n, negative 1 over n into brackets x minus x squared, like that. Then cosine nx. Okay. Then here we are subtracting. So this negative and this negative will give us positive. This negative here and this negative here will give us positive. So I'm going to have plus 1 minus 2x. Sine, we have 1 over n squared. So we have 1 over n squared. I should have written it here, but Let me just write it here, there. This one will be sine nx. Remember, we are just simplifying the equation for the function. Then we move on. This negative here will cancel with this negative here. Then it will give us positive. It will give us positive. That will be positive 2. Of course, 2 times 1 over n cubed will give us positive 2 over n cubed. Remember, this cos nx supposed to be here. It's only that I'm limited with the space. So this will be cos nx, like that. Then I will close our bracket, the interval negative pi to pi. Okay. Then up to there, we now recall that in our previous lesson we said that any function times sine nx, any function f of x times sine nx gives us 0. Any function f of x times sine nx gives us a 0. And we said that this one is an identity. We said that this one is an identity that should be at your fingertips. So any part with the sign is gonna cancel. Any part with the sign will cancel to 0. So that part there has cancelled to 0. Then we now proceed together. We now proceed, and we're going to have our bn being equal to 1 over pi, being equal to 1 over pi. We're going to have our n being equal to 1 over pi into brackets. Okay, into brackets. So we're going to have negative 1 over n into x minus x squared nx. Okay, nx. And then plus, this one has cancelled to 0, so it will be plus 2 over n cubed cos nx, like that. Then we put our intervals like that. We proceed. I hope you are proceeding well. Now we are going to open these brackets so that we are going to have bn, b sub n will be equal to 1 over pi into we will have negative 1 over n times x will be negative 1, that is negative x. It will be negative x over n, negative x over n cosine nx. So we are supposed to, we have made an error somewhere. This one is supposed to be cos nx. That's an error we meant. Supposed to be cos nx. And we now negative 1 over n times negative x squared will be positive x squared over n. That one is cosine. That is cosine nx. It will be cosine nx, like that. Then now, lastly, plus 2 over n cubed cos nx, like that. Remember, we are still working with our intervals. Then now from there, we are going to substitute in. We're going to substitute in our intervals. I'm going to substitute in our intervals. So I'm going to substitute first pi where we have x, then negative pi again where we have x. So that now bn will be equal to 1 over pi into this will be negative pi over n cos n pi, because there is x, plus pi squared over n cos n pi plus 2 over n cubed cos n pi. Then now we subtract. Okay, there we subtract. We now subtract. We substitute in negative pi. So it will be minus. We open brackets. So negative pi times negative will give us positive pi. So it will be positive pi over n cos n pi. Okay, we proceed here. We proceed to the next line. Proceed to the next line. Plus, it will be plus negative pi squared will give us what? Negative pi squared will give us pi squared. Will give us pi squared over n, pi squared over n cos n pi. Then finally, plus 2 over n cubed. 2 over n cubed. 2 over n cubed cos n pi. Like that, to close brackets. Then I want you to remember that in our previous lesson we said that cosine of n multiplied by negative pi is the same as cosine n pi, and we said that this one is an identity, and that's why you are not seeing negative cos negative pi cos negative pi cos negative pi in our second substitution, where we are substituting negative pi. So now we proceed by opening the brackets. We now proceed by opening the brackets. And therefore our bn would be equivalent to, our bn will be equal to, our bn will be equivalent to 1 over pi. So I want us to open the brackets together. Be equivalent to 1 over pi, negative pi over n cos n pi plus pi squared over n cos n pi plus 2 over n cubed cos n pi. Then now we start opening the brackets. This will be negative pi over n, negative pi over n cos n pi, this one here. Then negative times positive here will give us, let's continue here, will give us negative pi squared over n, that is cos n pi. Negative times positive, this one negative here times positive here will give us negative also. It will be 2 over n cubed over n cubed cos n pi. Now we close our brackets. Then there are some terms that will cancel here. Some terms will cancel out here, and some terms will cancel out here. Sorry, this one is supposed to be which one? Okay, it's okay, it's correct. So this here plus 2 over n cubed cos n pi will cancel with negative 2 over n cubed cos n pi. Okay. Positive pi squared over n cos n pi will cancel with the negative pi squared over n cos n pi. Then we are going to remain with negative pi over n cos n pi and negative pi over n cos n pi. Of course, there are two. Therefore, we are going to simplify our bn. Our bn will simplify to 1 over pi into, because there are 2, we are going to have negative 2 over n cos n pi, like that. Because there are 2, I'm going to have negative 2 pi over n cos n pi. Okay, this pi will cancel, Then this will simplify to negative 2 over n. We'll simplify to negative 2 over n cos n pi. Then you can recall what we said in our previous lesson, that cos n pi is usually equal to negative 1 to the power n. Therefore, this one is just an identity that we are applying here. Therefore, our Bn or B sub n will be equal to negative 2 over n, which is here. Then we substitute where we have cos n pi, we substitute negative 1 to the power n. So it will be negative 1 power n. So this is the value of B sub n. This is the value of B sub n. So thank you so much for watching. I hope you understood. Please subscribe, share, comment, and also like. God bless you.